Hello, we're going to solve this problem. Leetcode 1062, longest repeating substring. Given a string S, return the length of the longest repeating substrings. If no repeating substring exists, return 0. So um, basically, we're going to check if we have any repeating substring on the given string, and if we have repeating substrings, we're supposed to return the longest one. Let's take a look in a few examples to have a better understanding. So this is the example proposed by the Leetcode. So for this one, we're supposed to return 0 because we have a string composed by A, B, C, D. Since all the in this string we have only different letters, there is no repetition, and we're supposed to return 0. For the second string here, um, we can see that we have a repetition from AB, so the output will be 2. And we have also a repetition of BA, that doesn't matter because it's the same size, so the output should be still be 2. For the third input, we have AAB, which repeats 3 times, but we doesn't care about the third time. We just care about the if repeats. In this case, the output will be 3. Okay. Um. So many people would thinking about, okay, I can basically generate all possible combinations and cache them in a hash map, and the one that repeats only once is the correct one, um, which means that there is only 2 occurrence and repeat once. That would be a way to solve this problem. Um, but I think that we can do better than this. Let's take a look with more attention here. Let's first see how we can express and thinking about this problem. So, how can we solve this problem for the first case? So, if we start with the character A, how do we know that the character A doesn't repeat in the string? We have to check all the possible others character one by one, right? In other words, um, we need to take a look if the character A exists in the string B, C, D. If it's not, it means that it doesn't repeat. We will do the same for the character B, but this time would be the string CD. We're going to do the same for the character C, and now the string is D. And since none of them repeats, we can say that the output is 0. Let's take a look here for the second input. So let's start with the character A. So we're going to look the character A for the string B, B, A, B, A. So we can see that the character A repeats for the this string, so we can um, stay with this candidate, which has size 1, and now we can look for the next candidate, that would be AB with size 2. So now we're going to look for AB with size 2, and we can remove the first A here just because this B is part of the um, is now part of this string. So we can remove it from here, and we're going to see that the AB exists in the middle right here. So we can say that the candidate with this output is true, and this is actually the number that we are looking for. So we can assume that this will work in this case. So what we are doing here, we started with a single character and we end up having two characters um, because the previous character was included in the string. If you go to the third case, you will notice something very special here. So starting, let's see if A exists. A exists, so we can say that A exists twice. So A is a valid string. So let's go to the next one, which is AA, just because this A is close to the previous A. So let's see if AA exists. AA exists because we have AA here. So we can go to the next one, which is AB. So let's go to AB. And you can see that AAB exists. So notice that this looks very close for a dynamic sliding window. If you notice here, we have a dynamic window with starting size 1, which is the string that we are comparing to. Then once this string is valid, we increase the size of the search window to 2. And once this is valid, we increase the size of the search window for 3. And we always ask if this string exists in the rest of the string. So if AB exists in this string, we can say that this is the valid solution. So our algorithm would be having a slide window that will increase the size whether we found a substring that repeats. But this will work for the example inputs that we have, but for one specifically here, it will not work. So if we have this string, let's see what happened. So we first start with A. We see that A repeats, so we increase the size of the slide window. Now we have AB, and we see that AB repeats here. So we increase the size of the slide window. Now we look for ABB. We can see that ABB exists right here. Now we increase the size of the slide window. And let me just do a straight line here. Okay, now increase the size of the slide window and we look for ABBA. If you look for ABBA in this string, it will not work because ABBA is not inside of the rest of the string. Actually, ABBA is inside of the this substring here. So it's not like compare what we have inside of the slide window with what we have outside of the slide window. What you're supposed to do is compare what you have inside of the slide window from the starting index, which would be this one, with the rest. So this is just a counter example of this approach, and that would be pretty much it. Once you have one single character, the rest of the string would be basically this. And once you have, for instance, two characters, which will be this side, this case, the rest of the string will be this. So now that you have a better understanding, let's move to the solution. Um, Initially, we going um, iterate through this string, and we're going to start with a slide window of size 1, and we're going to check if um, if this string contains uh, the sliding windows um, word. So first, let's start extracting the sliding window. So let's call this by candidate. So we're going to do as substring I, which is the initial position, with size W, and we need to um, have the rest of the string, which will be called by reminder. That's not actually reminder, but I don't have a better name for this. So the size of the reminder would be um, the whole string uh, minus a minus I, and we're going to start from I plus 1. Um, so let's see. Going to start with I plus 1, and we're going to have size. That would be I minus 1 here. And we're going to check if the reminder contains the candidate. So we can create like a method here, just for save some time. Contains reminder contains candidate. If contains candidate, we can increase the size of the window, and we need to decrease the I because let's take a look again in the example. If we are in this case where we are looking for A and we see that A exists, we're going to increase the size of the window, and we need to compare this same sliding window still starting from element A. So whether we have a value substring, we cannot increment the string iterator. We need to stay in the same place and compare the window for that place. So we're going to check if we contains that value. If we contains, we are good. We increment the window and we decrement the iterator to stay in the same place. There is just one thing that doesn't look right here, is that we're supposed to iterate not until the end of the string. We need to like have a safeguard here to make sure that we're not going to access invalid position. So I will decrement the size of the window here. And once we have this, we can return table minus 1. Now let's implement the function contains. To implement the function contains, it will return a boolean. It will receive two strings. So string 1, string 2. And if string 1 has size less than string 2, we can just return false. And we can use a method in C++, sorry, size. We can use the method find to reduce the code. str1 find str2 different from string and pause. it's happening. I believe that we're supposed ready to go. So let's take a look in this example that I showed early. So let's see if this works. Okay, this works. Um, we can submit this. Um, we can see that we have a very good runtime, and we have 13 megabytes of memory usage. We can save some space if instead of using strings, we use string view. It's a C++ hack. So string views are like pointers. We are not performing copies, whether we have a substring call. So I will just replace the s by svs. And instead of string here, I will put string view. Same for here. You don't need to forward the string views as const reference. Don't worry about this. And let's see if this works. Okay, let's submit again. So now we have a incredible performance increase, and also memory usage decrease a lot. Can you do better? Maybe we could move this contains method outside of the class and mark it as inline. So maybe the compiler will increment, optimize this for us. The runtime wasn't so that good as the previous one. That's kind of randomic, but the memory usage, it's very good. So yeah, I see that we have a good solution here. If you take a look for the complexity analysis for the code that Leetcode provides to us, it will say on square, which is true if you considering that the worst case scenario, the window size would be equal to the string size. This could happen because we have on here, and we eventually going to have another on here during this comparison. So we have on square. However, for the space here, the AI say that we have on. However, it's actually O1, just because with string views, you are not allocating uh, the whole string, you are just allocating one single pointer. I can even maybe reduce this by not allocating this pointer any times, but I could put this here. Let's see. And this one here. So now it's O1. Previously was actually ON. Let's see. Um, so that's still ON, but in fact it's O1 because we are just allocating this once. So that's pretty much it. Thanks for watching.